Well, hi, good morning, and thanks so much for joining me here in my shop. And today is May 30th. Wow. And I'm going to do the last alignment steps on this radio. Yesterday I aligned the IF circuits in it, IF stages, and today it's the rest that's going to be aligned. But first, look at this fantastic display of phono plugs. There's something about one of these, and don't say one of them has no wire. That's not what I'm after. So I mentioned that on the back of a lot of these radios there'll be a phono plug. There's one on the back of this radio. And some of those phono plugs, not this one, but some of those phono plugs are actually switches, and they require a certain kind of phono plug. I guess this is the plug, and the thing on the radio is the jack. Maybe I got that backwards, but they need a special kind of phono plug to operate properly. So I thought I'd show you what one looks like. So this is typical. Let's hide those two. This is typical of what phono plugs look like. And when you look at the end of the pin here, and when you compare it to this one, there's a difference there. That's a substantial difference. This one is designed to operate that kind of switch. You can tell this is an older guy. I don't think this has ever been installed. It's brand new. It's never been installed on a wire. So this is so long, it goes in so far, it actually separates a couple of contacts in the back when it goes in. It goes in, goes like that, separates them, and that's a switch. So there you go. If you plug one of these in, it's not likely to operate the switch. That's all for that, just in case. This is a little bit obscure information, so that's why I'm sharing it. Now, let's get back to aligning this radio. So this is this radio has an oscillator and 2 tuned stages in it, which means it should be a really good performer once we get this done. It looks to me like all the adjustments take place here, just on those 3 trimmer capacitors. Certainly in terms of the ganged capacitor, that's where the trimming is done. Now, is there anything else here? Well, let's take a look. We'll take a look at the instructions here and just see what it says. Okay, so we're looking at the table of guidance here for doing an alignment. I've done steps 1 and 2. We're on 3. So we're not feeding in through the antenna yet. We're skipping the antenna and the first stage of tuning, and we're going to feed the signal right into the first RF amplifier. We're going to feed it through a capacitor. As I mumbled yesterday, they call it a dummy. I wouldn't call this a dummy, but then maybe I'm the dummy. Set the gang at 1460. Adjust for maximum output on, look at this, oscillator and interstage trimmers. So they're not being terribly specific here. Oscillator and interstage trimmers. I think this will be pretty easy to figure out, though. Just so, but that's 2 trimmers. This one says antenna and interstage trimmer, so I think it's referring to the same one again. Check only. Nothing to adjust down here, and here we're using the antenna to blast in the signal. Okay, so we can get through this one, I'm pretty sure. First thing we got to find is pin 1 on the 12BA6. Pin 1 on the 12BA6. Okay. Pin 1 on this 12BA6. Pin 1. Okay, pretty easy to spot right here. Once again, still all the original capacitors are in here except for the main power supply filter capacitors. So the radio's still operating with what might be pretty tired out capacitors in it. They don't look it though. So we're going to want to make a connection up onto pin 1. Pin 1 is here. I'd rather lay the radio back down. I think I can do that because there's no end plate on the chassis here. Cheap chassis, eh? Just take a flat piece of metal and just bend the sides in and forsake the ends. like that. I think that's going to work. Okay. Get up those three easily. Those three easily. Okay, I guess we should turn on the radio. Turn on the meter and our signal generator. Let me turn the radio on and get it warmed up here. Okay. The frequency we're supposed to do this at, I'm just going to peak myself at the documenter. 1460 is where we're operating. 1460. Oh, not going to get there. $60. Okay, and we'll tune the radio to 1460. How do we know the radio is tuned to 1460? How do we know that? Apply signal. Set gang at 1460. How am I going to do that? So often they have marks, and look at them all on here, that indicate different frequencies. Must have been a little dirt on the volume control there. So this one has these nice little holes drilled into the backplate marking test frequency. So this has got to be 1460 up here. You can see the capacitor's almost closed. Okay. Now one thing is the pointer in the right spot on the string. Okay, it's possible this very first one is that. So let's go check it out. I don't think it said anywhere in the instructions how to ensure the pointer's in the right spot. Here we come. Right by it. Okay, so question. Is this pointer in the right spot? And the answer is, geez. Let me look at the manual again. Let's take another look at the manual and see if these marks are referred to or come up in any way, shape, or form here. Okay, it looks like my own personal computer screen here is breaking down. I hope I'm not right in the middle of making a video. My computer's failing. Let's hope not. Okay, it doesn't come across on the video at all though. So here we go. And well, what are we doing? I forgot totally why I was going to look at that. Oh, man, I'm so easy to distract. Oh yes, any hints about the front panel? Hints about the front panel. Hints about the front panel. You know, they would tend to put them in here somewhere with the stringing. So it says gang completely in mesh. Where's the pointer on here? They don't even show it. The pointer is probably on this one, this string. No pointer showing. What about over here? Now this is one for my radio actually. It says 3 turns here, not 5. I must have read that wrong at some point. 3 turns makes more sense, but no pointer showing. Stringing detail, tuning range. Uh-oh. There is just nothing here to tell you where the pointer should be. There has to be. In fact, without that information, it's actually really not possible to align a radio properly. Oh my gosh. Oh, what was that? Yeah, so the radio just suddenly popped to life here. That's me fooling with the volume control. I think it's probably that it might be the tube that's still acting up. Come on, can I not get another? There's no hint on this. Give it up, Jim. There's no hint. You're on your own on this. Well, okay, let's go back to the radio here. I'm going to stop for a minute, and I've got to do something about my computer here. It's just going, a lot of bizarre things going on. So I'm going to stop and reboot my computer, I think. Oh boy, it's really something. Okay, I think I'm back in business. While I was fiddling with my computer there, this radio did exactly that. It's got to be this tube. It's got to be this tube. So I'm going to give this tube the WD-40 pin treatment and just see if we can get rid of that. And once again, how it is a oil like this works so well, I don't know, but I had a model train set. I still have the model train set. How hot is this? Oh, it's way too hot to touch, Jim. Don't touch it. Had a nice model train set, put it together for my young sons back when, and then the train tracks convey the electricity, of course, to the it was an older train set, and the tracks get a little dirty, and it had this fluid. It just came with the train set. It's no longer a story how I got it. I didn't go out looking for it. I was given it. But this green fluid is the same stuff I noticed in barber shops that barbers put on their trimmers, their hair trimmers and that. And they put a little bit of this onto the engine, and oh my gosh, what a difference. And it looked like green water. I have no idea what it was, but it was the solution. Literally, the solution apparently is well known among model trainers, train guys, to use this stuff. Wish I knew what it was. Eventually I ran out of it, and then from then on I had trouble. And I always thought I should go down to the barber shop, get some more of it. Oh, there's too much dust here. That was probably not a smart move. Okay. Grabbing the hot tube there, Jim. It's too hot. Cooler at the base, not much. Okay, this crazy operation here. Don't hold it like them. In you go. Do you think that had any effect? Sure worked on the other tube. Okay, put away the magic elixir. And this is our signal. Ooh, this should be on B-. I don't have a B- available up here, or do I? No, I do not. Okay, we're going to tip this up with it operating, so I just don't want to turn it on and off. And then we're going to go after, oh, it's way down at the wrong end of the radio. It's way down here. Okay. Okay. Problems have set in. Can I safely make a connection to B- and up here? So the B- comes up here somewhere, I'm sure. If we kind of trace along like I did before, this black wire is a B- wire. And it's connected right here. So this is a B- point. Is it? Is it really? Is there a voltmeter here handy? Somebody hand me my voltmeter. Where is it? Son of a gun. Okay, with the video off, the radio repeated that where it goes, kind of makes crackly sounds and then pops and stops. Maybe that tube thing didn't work. But let's just check. So we're going to look for voltage between the known B+ and the B- point and the suspected B- point. Just as some kind of confirmation of a sort. Nothing there. Yeah, I'm pretty sure. Not a good thing to get this wrong. So we're going to hook this up to this available pointers right next to a coil. Geez, is that a good idea, putting a big clip lead right up next to a coil while you're doing an alignment? No, that's the answer to that. So the B- is carried on this black wire, and it comes all the way to the terminal right beside the one I put this clip lead on. Oop, way up here, way up here. I get another clip lead in right beside the first, and that's a perfect spot. The radio operating. No, I don't think I think I'm just going to turn this off. Wow. Got my fingers all over it. Is that shorting right out against the other one? Wow. Almost. Wow, these are close, guys. Okay, I think we're safe. I think we're safe. I think we're safe. Power on. And we'll wiggle that tube once it gets going. So I'm wiggling the noisy tube. There's no noise at all. WD-40. How do you do it? Okay, we're ready now to feed in a signal. We're going to feed it into the grid of the first RF tube at 1460 while the radio... I haven't resolved the radio tuning thing. Okay. Now, what we can do is we're taking a look back here to see how this is on the string. Sometimes these are locked in with glue. Sometimes the string is wound through some tabs. Sometimes those tabs are squeezed down and locked right on the string. So you know the pointer has never moved from the day it was first put on in the factory. And this one, we're going to have to take a close-up look to see. This one, I don't know yet. Let's take a close-up look here. And we'll see. Where are we looking? Totally lost my mind here. Hold still. Let me set the focus so we can get right up close on it. Just bear with me a moment here. What I'm doing is I'm just calling up the dialog box for that camera. And we'll set the focus real close. And we'll take a look real close. That looks a little like glue on there, but I think it's a cobweb. So the tabs have not been bent. Now you can see the string just winding through them. None of them have been bent down. So the pointer is where it is simply because of tension in the string and nobody ever fiddling with it. It's interesting how they've done the pointer itself. It's almost like it's clipped in there. Huh. It's like a locking piece right on the top of this. How do they do that? I'm not sure how they've actually locked it in there, but they've done something. So now, are we in the right spot? Wow, that's quite a question. Still quite a question. So here's the 3 markers. Now, let's assume they've put these in here for a purpose. So there's one on the far right, and then one in the middle, and then we got these 3 here. So the way it could be is the first one here. What is that? Where did that come from? Did anybody hear that? Is that my head ringing? That was weird. Okay, I don't know what that was. A dinner bell of some sort. Okay, concentration. So the first one could be where the pointer should be when the capacitor is completely closed. The next one could be the start of the AM band at 540. I believe this radio starts at, that could be 540. This could be a checkpoint, typically 600. The radios like to use 600. That could be 600. This could be dead center of the band for some reason. Yeah, for some reason. And then this one would be 1460, the top. And then there's no hole to mark the other position of the pointer. There's only one down here. Now that would mean the pointer's off to start with. Like, this is a serious thing. If you really want to get this radio to work well, we got to get this pointer in the right spot. What would be another way to do this? Put the whole thing back in the radio cabinet and look at the numbers that occur around these points. Yeah, I'm gonna have to do that. I'm gonna have to do that to get any kind of certainty out of this. Okay, that's what we're gonna do. We're gonna stick this radio back in its cabinet and look at it. Okay, power off. Power off. Try and leave all those wires hooked up. Get in the cabinet. By the way, the radio I was working on before this one, if you're watching all my videos, I stopped a little bit abruptly with it. I never put it back in its cabinet. It said something about I'm going to refinish the cabinet. Well, I've started on refinishing the cabinet, just in case you're somehow interested in that. So that radio will come back in my shop in a refinished cabinet someday. Okay, so we're going to stick this in here. Can I do it? You know what? I can't leave these wires sticking out the end here. Oh, come on, really? All that time spent clipping it? Gotta go. Okay, the radio's in. You can't put this in wrong. That's kind of how this goes. Can't. Knobs. Whoops. Come down here. Look down here. Okay, so the knobs are centered in the holes. So I'm not screwing the chassis in, but the chassis can't move too. Yes, it can move a lot. What's going on there? How come it's rocking? And this one's protruding more than this. The radio's in further here than here. Oh, maybe it's because of this wire chain. Jeez. No, it's not because of the wire. Something up front. So all there is the light bulb, the speaker, and there's nothing in the cabinet. So I don't know what's going on. How come it's rocking like this? Can't, I don't know. Okay, just put it in again. The main thing is the radio can't be too far off left or right. Don't know. Okay. Now, let's get down to business here. Right, can't see a darn thing. The little holes are way up here. How are you supposed to see those? Oh, it's impossible to see them. Okay, so what we'll do is let's bring the pointer in here. So the very first thing is 5.5. You know what? There's marks on the glass. There's a mark here and a mark here. This clearly is not the end of the capacitor run. This one probably isn't either. There's still a little bit of a space there. Can you even see the mark? You can see this one over here under the 4. So they have them on here to help you set the radio. I wonder if I should just go up to this one. And so it looks like it's 14. So wait a minute. So there's a little black bump there for 14, and then just beyond it is the dash. This would be 14, 12, 10, 10, 13, 14, 15. Whoop, whoop. 10. Wait, 10, 13, 14. What? 10, 11. Boy, thank God I'm not doing the countdown. Hey, countdown today. 10, 11, 12, 13. Of course, I'm counting up. 14, 15. So yeah, that could be 1460 right there. So why don't we put the pointer to 1460? And it's still not going to resolve the pointer position problem. So let's see how far off the pointer goes off scale this way, because it goes quite a ways. So we'll get the better camera going here, because this is a real thrill. I know it's a thrill to see all this happening. Where's that pointer? It's very hard to see in this radio, isn't it? You can see the dash, the pointer is very hard to see, but it's going to move. There it goes. Okay, so it's at the edge of the dial, but I haven't reached the edge of the motion here. Or have I? No, it goes quite a ways. Oh, it goes to there. That's quite a ways. So it's disappeared way up behind. It's up around the C. Okay, now the other side, the assumption is these things would be fairly balanced, you know, would be symmetrical. Because engineers like things to be symmetrical. I'm going to kill myself unless I put it on back on here. Okay. Where's it going to end? Clunk. So you're hearing the string pop. That sound is the string popping on the shaft. That's the end of the run there. The actual sound is the string. First I'm turning this, I'm pulling tension on the string a little bit, that nothing's moving. So the spring is being extracted out, and then the string slides on the shaft. It goes back, the spring goes back and makes that spring sound. There. That's actually a very complicated thing that's going on to generate that. Okay, a lot of fun. Just having fun with the radios here. So the pointer is stopping just above 15. That's what I see. And it really should be stopping maybe at the edge of the thing here. So now we have a number of indicators that the pointer is too far to the left, including the original one, which was the first hole. Okay, I think it's pretty clear. Pointer's not in the right spot. Pointer could easily have been moved by anybody at any time. So this step in the alignment isn't even talked about in this particular schematic. A lot of them do. So we think it should stop here. I think, and that's just about right. That's just about the distance that it's not making it. Okay, now we got to move the string. Move the pointer rather. So moving the pointer on the string, there's an intuitive thing that you have to do, a non-intuitive thing. So you might think if you're gonna, how can I model this on my bench here? So let's say that's the string, and here's the pointer, like that, and you want to move the pointer this way. You might think, well, I got to resist the string movement, so I'll hold the string here. I'll hold it with pliers or something, and then I'll push this along the string. It's actually opposite of what you should do. You should hold it here, and then when you go to push it, you'll build slack through here, and the slack will allow the pointer to move on the string. It's counterintuitive. If you do hold it here and then try to move this way, you'll actually pull it tight into the clips, and you'll start fighting with the string something terrible. So hold it here. And now, as usual, when I make these statements, I now try it and see if I'm telling the truth. Okay, so we want to move this up to there. So I'm going to clamp the string with my finger here. There's a fair bit of tension on the string. Okay, it's clamped. I hope it's clamped. Now I'm going to move this. Look as simple as can be. And I can't move it back. If I move it back, I'm doing that tension pulling thing there, which I don't want to do. So there we are, pulling in the right spot. Wow, there's a lot of talk for just a moment of change. So now we think this would be not that. This would be either it's just appearing in the window, or this is the first frequency the radio is intended to receive. And this would be an alignment check spot, probably 600. Let's look back at the, in fact I'm just going to do it on my own. I'm going to take a quick peek at the instructions here, and it says there's an antenna check at 600 kilocycles, so that's probably the 600 kilocycles. So this would be the 1460 for sure. And this, we don't know. There's nothing said about anything in the middle. Okay, fantastic. So we're starting up here. Pointer in the right spot now. Well, it's in a righter spot. I think we can be fairly sure of that. Hook up the meter before I hook up the signal generator, rather. Go back through this careful clipping process here. Okay, and we'll put that on when we need to. Just hang there now. There, meter's on. Where are we set here? So just double checking on the chart again. 1460 is the frequency. Kenneth. Okay, that's as about as accurate as I can get that. 60. Radio on. We need the radio on at this point. We're not going to get too much further without it. So we're modulating this with 1,000 hertz at at 30%. Took me a while to finish that sentence, didn't it? 30% modulation. Here we go. Hook this up and we should hear the tone. The tone is being fed at a fairly, this is like a moderate signal. probably come right through. Well, it depends if the radio's tuned. Ooh, there's that popping in. I think it's the volume control. Okay. So we got this at 1460, and we got that at 1460, and they're not hearing it. So alignment issues galore here. Since I've moved the pointer on the string, if somebody previously did align it, then that alignment's invalid now. Let's find out where this really is. 15. $14.60, and you want to adjust the oscillator. So leave the radio up like this. No, I want to set it down. Son of a gun. I'm going to turn it off just because there's too much hanging around here. Set it down. I want to wear a radio out fast. Turn it on and off and on and off and on and off. On and off. Let it cool down every time in between. Okay, so we're still on 1460. I get a better look at it here. Now the 3-part capacitor here, one part is going to be the oscillator. I'm pretty sure it's this part here. Let's adjust this so we can hear it for now. Okay. So I want to make sure I know which one's the oscillator by fiddling with this. Oop. So this one has to be the antenna. Here's the antenna wire right here. So that's antenna. You can take a wild guess. This is intermediate, and then this is oscillator. But I want to be sure. Oscillator here. Now the reason it's getting louder when I'm touching the scatter plates here. Okay. Just touching it. Because I very cleverly did not tune this signal generator directly onto the radio. I tuned it close so I could be more sensitive when I did this. Expecting the radio to either tune further away and the signal disappear, or tune in towards the signal and I'd hear it. Oscillator. Okay, no doubt that is the oscillator. So what about it? So we put this down where we want to go and give it more juice here. Down, down, down. And figure out whether to turn this capacitor forwards or backwards. Wow. Oh, pulled the plug. I pulled the cord out. How come your meter's not showing anything? Okay. Strengthen it up. Okay, now we'll put this properly on 1460. And we'll cut this back. See if we can find it. So you can hear the screw, its movement instead of being smooth is jumping because I'm using a plastic tool here. Listen. Oops. Try that again. There. So very, very hard to successfully tune a radio with this kind of problem. That's why I like to use metal screwdrivers. Check for interference or problems. It's a capacitor here. it shouldn't really cause a problem. A stiff shaft will let me control the position of this screw with great fidelity. Back and forth. So there we are. So now we got 1460 on the signal generator. We got 1460 on here, and that's good. That's good. Now it also says do the interstage trimmer. So since I can see the antenna connection, it has to be this one here in the middle. Interstage trimmer. Watching the meter. Down. Oh, another trimmer that wants to go wide open. So I'm going to tune it in just a little bit. Son of a gun. Okay, that's great. So actually, we finished line 3 on the chart. Great. Let's just stop here for a bit. Okay, wasn't much of a break. So what I've done here is so I've removed the connection into the radio here. So radio's just standing here all on its own. Hey, let's try tuning something in before I go any further. Yeah. See if it's improved much already. I think that's 680. That's a tough one to receive. The next should be 640. Should be pretty easy. And then the next one would be 590 would be next. That's a sports channel. They're always talking about sports. So talking about hunting. So okay. So there we are. So it's improved because I had trouble picking all those stations up before. But the real magic is picking up the French one, but oh, the magic is in. Very good. Okay, now we want to go the next step. So rather than hook anything up to the radio now and disturb its operation, the way I'm going to be sending the signal generator signal to the radio is literally into the antenna from this one, from this other radio antenna. So I just hooked up my signal generator just to this. This looks kind of fancy. It's not. There's nothing going on over here. So we want to put in 1460. I boosted the signal on my signal generator, and we'll tune this guy. 1460 is supposed to be right here now. Beautiful. Beautiful, there's no noise to interfere with what I'm about to do. And right on the money. Okay, and what are we going to do? We're going to adjust. Hang on one sec here. Let me just take a look at the guidance. Antenna and interstage trimmer. So, antenna and interstage trimmer again. So we do the antenna. Very, very distinct peak. That's reassuring. Okay, interstage, this one I turned out all the way. still wants to go out all the way. So maybe we get around to changing some capacitors underneath. That might affect this. That might be something worth looking into. So what's the deal now in terms of receiving? Can't imagine it's much different. I should look more closely where it was tuned when I got that French station. Son of a gun. Okay, we'll go down here. .680, clearer. 640, a little bit clearer. That's 590. Oh, 740 coming in. Getting louder as I come up here. So there's no stations up here really to listen to. All the stations are down here. So I'm going to go back to one of them. Opening this up made it louder.
You know, my buddy Mo Sues, they used to work out with me when I owned Full Metal CrossFit. Now my buddy Dennis owns it. He opened up a CrossFit gym in Cambria, and
okay, so that means I think this situation is the alignment cannot be considered anything that's dragging this radio's performance down at this point. If it's not performing as well as it should, then it's something else that's going on, and what's left are all those capacitors, which is kind of just where I wanted to get the situation to. Now, I'm not going to do any. I'm almost finished for today. Tomorrow I will start working on these capacitors, and we'll try to do them as usual in some kind of sensible order, or try to pick off any of them that might be responsible for bad performance. Although performance isn't really all that bad, but I think it can be better. And we could even try that measurement of the microvolt gain. That's a tough one to do and be sure of when you've done it. So that's it for today, though. Fantastic. It's coming along. It's coming along nicely. Thanks a lot for watching.